All right, guys. Yesterday, I honestly, I agree with you. I don't know about the height, but all right. Yesterday, we talked about adding and subtracting fractions, our grown-up fractions, which are rationals, right? In order to add or subtract, you have to have a, tell me, common denominator. Very good. So looking at this, all right, there's a lot going on here. What I like to say is figure out what your common denominator would be, and then you look at each fraction separately, figure out what each fraction has and what it's missing. So if you look at the first fraction, it has 1x and 1x plus 2, correct? The second one has 2 x's, and the third one has 2 x's and an x plus 2. So if I was going to make a combination, if I was going to figure out what the common denominator would be, what would it be? What do I need to multiply everything by so it would be all the same? Let's look at it. Oh, it's freezing. 2 of my fractions have an x squared. One of them only has an x. 2 of my fractions have an x plus 2, and one of them doesn't. So what do you think the common denominator, how would we figure out what our common denominator is? Talk to me.
Is it x squared, x plus 2?
It is. Very good, Mia. It's x squared and x plus 2. Miss Ferry, thank you so much for my salad. It was delicious. Thank you for getting it for me. All right, so now, guys, we're going to go through the process and figure out what each fraction has and what it's missing. So my first fraction has an x and an x plus 2. What is it missing? An additional x. So if we multiply the bottom by x, we have to do what? Multiply the numerator by x. All right, look at your middle. It has the x plus 2. What is it missing? Sorry, just kidding. Told you the answer. It has the x squared. What is it missing? X plus 2. So what we do to the bottom, we do to the... Thank you. And then my third. Do I need to multiply anything? No? Okay, good. So now let's just simplify a little bit here. I'm going to distribute. So I have what in the numerator? 6x minus x squared. God bless you. Agreed? Plus x squared. Keep going. Hold on. If I distribute, I have x times x is x squared. X times 2 is plus 2x. 2 and x is going to give me another 2x. And then 2 times 2 is 4. And then plus 8. Yeah? Everybody okay? Now what can we do in the numerator? Can we combine like terms? We can simplify. Does anything have an x squared? I have a positive x squared, good, and a negative x squared. All right, what else? 6x plus gives me, perfect. And then what else? 4 and 8 is? 12, good. No, it's just an ill circled. It went right through the addition sign. So x squared, God bless you, x plus 2. If you guys wanted to, how could we simplify a tad? Okay, we could factor out, there you go, and then have 5x plus 12. Yep. Thank you.
Could both be accepted as an answer?
Sure.
I think there were some correct answers on WebAssign that they didn't accept, like they only accepted like a specific one.
Yeah, sometimes WebAssign's funny like that. I'm not as funny. But remember, guys, your test is going to encompass everything that we've done. So your quizzes, all of chapter P. So we need to be on top of all those things. All of it. I just said it on the video. All right, let's go. Chapter P, Section 5, Part D. We're almost done with our prerequisites. Rational expressions with complex fractions. Okay, this can be overwhelming at first when you see it, but if we're going to just go step by step, it's going to be all right. You guys are going to be fine. All right, we have 2 options. You can find the LCD of each fraction, multiply each term by that LCD, then simplify. Or you can find the LCD of the numerator and the denominator separately, then say change flip. All right, we're going to just practice some. We'll talk about what is easier for each of us. If I have questions that are like on this first slide, do you guys agree with me that this just says a fraction divided by a fraction? All right. Do I have in my numerator here, do I have in the numerator 2 fractions that I'm adding or subtracting together? No, I don't have to figure out common denominators or anything like this. So these are pretty basic. I can just say I'm going to keep, Miss Chris Weiser says stay, change, flip. I say keep, change, flip, but keep, change, flip. I'm going to keep my first fraction or rational as 1 over x. What am I changing my division sign to? Multiplication. And then when I flip 1 over x squared, it becomes x squared over 1. Good. And then we simplify. How can we simplify here? Cross out an x on the bottom and 1x on the top, and I'm left with just x. You guys agree? Everybody okay? All right, just getting along. You good? All right, again, I just have a fraction divided by a fraction, so I'm going to keep, change, flip. I have 1 over x minus 2. Remember, if you want to get in the habit of putting your binomials into parentheses, that might be a good idea. I'm going to change my division to multiplication. And then when I flip, this becomes x squared minus 4 over 1. Yeah? All right, what do you say, Hannah? Hannah sees difference of perfect squares. I totally agree. So x plus 2, x minus 2. Good. Can we cancel anything now in any numerator or denominator? Yeah. Yes, an x minus 2 in the top, x minus 2 in the bottom, so we're left with x plus 2. Good. All right, moving along. Same thing, in my top fraction, I'm not adding, unlike denominators or anything like that. So again, we can just keep, change, flip. I have 1 over x squared minus 9 times what? What am I multiplying by? Okay, x minus 3 over 1. Do you guys see anything that we can factor? Difference of squares, okay, so x plus 3, x minus 3. Agreed? Okay, so anything on top and bottom that's exactly the same? The x minus 3 is good. What are we left with in our numerator, guys? 1. I don't see anything there. If everything divides out, remember you're left with a 1. It's not a 0. It didn't just go anywhere. And then what's my denominator? X plus 3. Fantastic. Good job. All right, let's look at number 4. How is number 4 a little different from the first few examples we've done? Okay, I see a whole number. Do you guys see these? All this is 2 separate addition or subtraction problems that we did yesterday. That's it. So personally, I'm going to simplify the numerator. I'm going to get a common denominator and get that as simplified as possible. I'm going to do the same thing with the denominator. Then I'm going to worry about keep changing and flipping. I think that's the best way to attack it. If you want to do something different, up to you. I'm focusing right now on just the numerator. Okay, so I'm going to rewrite it over here. I'm going to rewrite 2 over x minus 3 over what? 1. Okay, I'm focusing on my numerator of my fraction. What is a common denominator, guys, between x and 1? X, okay. So if my first fraction is 2 over x, I don't need to do anything with that. What do I have to do with my second fraction so the denominators would be the same? I have to multiply the bottom by x. If I multiply the bottom by x, then I multiply the top by x. Do you guys agree that this becomes minus 3x? Okay, good. Now I'm going to focus on my denominator. I'm not flipping or anything yet. I'm just focusing on my denominator. So I have 1 over 1 minus 1 over x minus 1. Everybody with me? What's my common denominator between 1 and x minus 1? X minus 1, agreed. So what do I have to do? My first fraction, what do I have to multiply the denominator by so it looks like x minus 1? I'm going to say x minus 1. What you do to the bottom, you do to the top. Perfect. So this becomes x minus 1 minus 1. Everybody with me? Okay. Can we simplify a little bit? Okay, I'm going to leave the numerator alone for a second. Again, I know you guys are going to skip steps and stuff like that. I understand. I just want to try and put everything out there for you to see. What can I simplify here? Correct. It becomes x minus 2, correct? Over x minus 1. So these problems are not any more, well, they are more challenging. I shouldn't say that. But nothing new is coming in this section. A complex fraction just means it's a little harder. You have fractions, God bless you, within fractions. So now we have created a problem like the first three examples. Can we now keep, change, flip? Yes, we're going to keep, change, flip. And this becomes 2 minus 3x over x times, when I flip, what happens? X minus 1 over x minus 2. Perfect. Yes.
What did you do 2 minus 3x?
Where did I get it?
Yes.
From over here, when we found our common denominator between x and... Okay, so now we get here, and I say, okay, let me see. Is there anything that is exactly the same on the top and bottom that I can simplify? No. There isn't. If you guys have a problem like this, you're going to get here, and some of you are going to go, I did something wrong. There's something should cancel out. Don't doubt yourself. If you need to go back and check your math, that's fine, but that's it, guys. There is nothing more to simplify. This is just 2 minus 3x times x minus 1 over x times x minus 2. There's nothing else to simplify. I'm thinking. Okay, so that's it. We're good. All right, so we're going to run through a bunch of examples just like this. Tonight, you guys have a homework assignment. Just four web assigned questions for practice. If you can get it done in class, say great. If not, no big deal. Just work on it. But the PDF that is the practice for this is not due until Tuesday morning. So if you want to work on it, that's fine. Come ask me questions on Monday. That's fine. We'll go over it. But you don't have to do that this weekend. You do have to do the website now. All right, so let's look at this one. Again, guys, deal with the numerator by itself and then the denominator. So my numerator, would you guys agree with me, is x plus 5 over 1. Okay, I have nothing that I need to add or subtract, multiply or divide there. So perfect. I'm just going to leave it alone. And now I'm going to say, okay, let's deal with the denominator. So I have x squared over 5 minus 5 over what? 5 over 1. Go ahead. Any whole number you guys have, write it over 1. So you're seeing, oh, it's a fraction and a fraction. So what's my common denominator going to be between 1 and 5? 5. Perfect. So if I multiply, hold on, I'm trying to keep it color-coded. So we're going to keep our numerator of x plus 5 over 1. If I multiply to get a common denominator of 5, x squared is going to just hang out. What do I have to multiply my 1 by to make my denominator 5? So what you do to the bottom, you do to the... Perfect. So this is x squared minus 25. Now that we have simplified our numerators and our denominators as much as we can do what? We can keep, change, flip. So I'm left with x plus 5 over 1. I change my division to multiplication. And when I flip, what happens? X squared minus 25 over 5. When I flip, what does that become? 5 over x squared minus 25. Are you guys okay with me writing x plus 5, x minus 5?
Oh,
At this stage right here, when we got our common denominator. Hannah, look.
Oh, I put that 5 times 5 is 10.
Oh, you silly girl. That happens a lot. That's okay. All right, now, does anybody notice anything? What do you notice? The x plus 5 here, the x plus 5 here. So you're left with 5 over x minus 5. Good. See, these aren't as scary as they look. When you first look at it, you're like, what? Just take it piece by piece. No big deal. And then you get to this, right? You're like, seriously? All right, look at your numerator. Is there anything you need to do with that numerator? Do you have two fractions that you're adding or subtracting together in the numerator? No, so just rewrite it. X squared minus 1 over x. So then I look at my denominator. Do I have anything that I'm adding or subtracting in the denominator either? No, I have x minus 1 squared over x. Oh, okay, well then, am I already ready for the keep, change, flip stage? What else can I add or subtract in my yellow? Can I add or subtract anything in yellow? Or anything in pink? No, we're ready to just keep, change, flip. So I'm going to keep x squared minus 1. Can I do anything with that? Can we factor it? Let's go ahead and factor it now. X plus 1, x minus 1. Okay, just get it out of the way. Then I'm going to change my division sign to multiplication. And then I'm going to flip. And when I flip, what happens? X goes on top. And what goes on the bottom? x minus 1 how many times? There you go. Very good. So now we can have a canceling party. What happens with my x's? They cancel. What else can I cancel? 1. Very good, my dear. 1, x minus 1. So in my numerator, what am I left with? X plus 1. Perfect. In my denominator, what am I left with? X minus 1. Perfect. Very good.
Could we have just multiplied the first fraction by x over x to cancel out the x in the denominator?
All right, scoot along. You guys are doing great. And then you're like, oh, great. Then you do this. We're fine. 6 and 1 are what kind of numbers? Whole numbers. What are they over? 1. All right, so let's just focus on just our numerator right now. I have 6 over 1 minus 5 over x. The only thing I'm looking at right now is my numerator. What is my common denominator going to be between 1 and x? It's going to be x. So if I multiply the bottom here by x, then I multiply the top by what? X. So I'm left with 6x minus 5. Everybody understand? Agree with me? You're okay. All right, so I'm going to focus on my denominator here. I have 1 over 1 plus 5 over x. What's my common denominator, guys, between 1 and x? It's going to be x. My first fraction needs an x on the bottom, so I need an x on the top. So this becomes x plus 5. Everybody with me? All right, so are we at the keep, change, flip stage? Yes, we are. We're at the keep, change, flip stage. So I'm going to keep 6x minus 5 over x. I'm going to change division to multiplication. And then when I flip, this becomes x over what? X plus 5? Perfect. Do you have anything on the top and bottom that's exactly the same that we can cancel out? Yes, our x's. Remember, your binomials are stuck together with plus or minus signs, so you can't cancel them. So this just becomes 6x minus 5 over x plus 5. Cannot cancel out the 5s, cannot cancel any x's because they're stuck together with other numbers with that plus or minus. How we doing? Okay, question. On a test or a quiz, does it confuse you guys or change anything when you have different letters other than x or y? Okay. I personally like just x's and y's. I really don't like the u's and the v's because when you guys write them, they all start to look like the same thing. So I think on our test, I might just change everything to x and y. If you want to do that right now, you're welcome to. Actually, let's go ahead and do that. Let's focus on our numerator. All right, my numerator, I'm changing the letters, guys. Stay with me. I have x over x plus 1 plus 1 over what? 1 over x, okay? We're just focusing on our numerator only. What is my common denominator going to be between x and, watch, put this in parentheses, x plus 1? X and x plus 1. Those are two totally different things, guys. You can't just add a plus 1 to the x. It's only multiplying a denominator to make it the same, not adding or subtracting. So I look at my first fraction. My first fraction has the x plus 1. What is it missing? An x. So I'm going to multiply the top by x. What's x times x? X squared. Good. My second fraction has the x. What's it missing? X plus 1. So I'm going to multiply the top by x plus 1. So do you guys agree this is plus x plus 1? Okay. Fair enough. So let's go to our denominator. Just take it piece by piece. Focus on the numerator, then the denominator. So I'm going to rewrite this again as 1 over x plus 1 over x plus 1. It is the same thing, my dear. Good. So it's x times x plus 1. Good. Whoops, forgot to put the 1. So my first fraction has the x. What's it missing? X plus 1. So what you do to the bottom, you do to the top. So I have x plus 1. My second fraction has the x plus 1. What is it missing? The x. So I'm going to multiply the top by x. So I have plus x. Everybody with me? Okay, so how can I simplify my denominator a little bit more before I keep, change, flip? I have 2x's plus 1 over x times x plus 1. And then my numerator is just x squared plus x plus 1 over x times x plus 1. Now, when I have a quadratic, I have something to the second power. I'm always going to say, oh, wait a second. Let me see if I can simplify that. Can I factor it? Are there factors of positive 1 that multiply to give me positive 1, but add to give me a positive 1? No. So is this going to factor? No, but you always need to check. So now we're at the stage where we can keep, change, flip. My numerator stays x squared plus x plus 1 over x times x plus 1. I told you guys, if you want to change your letters, that's fine. Just be consistent. I'm going to flip. Well, let's change our division to multiplication, right? And then when we flip, what does our fraction become? When I flip my denominator, what does it look like? X, good, times x plus 1 over 2x plus 1. Awesome. Now I look, is there anything on the top and the bottom that is exactly the same? X and x, good. And my x plus 1, x plus 1. Don't leave your answer like that, guys. Be nice and organized. Make things pretty for me. So x squared plus x plus 1 over 2x plus 1. Remember, 2x plus 1 is stuck together in parentheses. That 2x is stuck with that positive 1. You cannot just randomly cross off x's because there's one on top and one on the bottom. You can only do that when they are being multiplied, not when they're attached with plus and minus signs. I say that a million times. You guys are still going to do it. It's going to make me cry. All right, last two. You guys are doing great. Then I'm going to go over your quizzes. Numerator and denominator. Let's focus first. I'm trying to stay with the same colors. It's not working. So my numerator, is 2 over what? 1 minus 2 over x. Okay, that's the only thing we're looking at right now is our numerator. What's my common denominator? X, perfect. So my first fraction of 2 over 1, it needs an x. I multiply the bottom and the top by the same thing. So I'm left with what? 2x minus 2. Now some of you are going to say, oh, you can factor out a 2. That's fine. We'll do it in a minute. All right, I have divided by. Let's focus on our denominator. Back to pink, right? Are you okay, honey? Okay. So then I have plus 2 over x. Common denominator. Okay, agreed. X. My first fraction needs the x in the denominator, so I'm going to go to the x in the numerator, right? So I have 2x what? Plus 2. Am I at the keep, change, flip stage now? Yes. Wait, let's choose a different color. Hang on. So we're going to keep, change, flip. 2x minus 2 over x. What do I change division to? Multiplication, and then I flip. This becomes x over 2x plus 2, yeah? All right, what can I cancel? My x's. Now, guys, if we leave our answer as 2x minus 2 over 2x plus 2, have I completely simplified this problem? No. What in the numerator can I take out? I can factor out a 2, so I'm left with x minus 1. What in the denominator can I do? Factor out a 2, and I'm left with x plus 1. Now, what can we do? We can cross off the 2's. Are we completely simplified now? Yes. Good. Sure. All right, let's look at the last one. This one's a little trickier because it's got some subtraction. It looks a little bigger. It's okay, no worries. Take your time. Let's focus on just my numerator. That's all I care about right now. So I have 1 over x plus 3 minus 1 over x. What is my common denominator going to be between x and x plus 3? X times x plus 3. Good. So now let's figure out what we have, what we need. My first fraction has the x plus 3. What is it missing? X. So we multiply the bottom and top by x. Good. So I have x minus. My second fraction has the x. What is it missing? X plus 3. Good. And x plus 3. Now I told you guys yesterday, however you want to do this, if you want to change this subtraction sign and stick that negative sign right there so you remember, woo, I have to distribute. You can't. If you want to write it like this, so it's minus x plus 3 in parentheses, fine. But you have to remember to do what with the negative sign? You have to distribute it. It goes here to your x, and here to your 3. So this leaves me with x minus 3 over x times x plus 3, correct? What happens with x minus x? It cancels. Everybody with me on that? All right, all we did was just focus on the numerator. Now I got to go back here and say, well, what's my denominator? Do I have to do anything with my denominator? I have divided by, what was it, 1 over x? 1 over x. Am I adding or subtracting fractions in my denominator? No. So are we at the stage now where we can keep, change, flip? Yes. So we're going to keep, change, and flip. I have negative 3 over x times x plus 3. I change my division sign to multiplication, and then what do we do? X over 1. Do we notice anything? Not a girl. Good job, Mia. So I'm left with negative 3 over x plus 3. Questions? Anybody have any questions? Nobody has any questions. Okay, what I would like you to do right now, I will upload this in just, yes, sir, sorry.
I have a question like the one before. That one here, how do you simplify the 2's into 1?
I factored out, if I have 2x minus 2, what's the GCF there? I took out a 2, right? If I divide out my 2, that 2 is going to go out in front, and 2 divided by 2 leaves me with x, and negative 2 divided by 2 leaves me with negative 1.
Oh, okay, so.
Yep, that's okay. In a sense, I did this, but not really, because you want to factor out the GCF first, and then if you can simplify out in front, simplify. All right, good.